Alright, let's start today's class. Okay. Well, probably is it like the last class before the long weekend? Is it? Okay, that's pretty cool. So exciting. Okay. Me too. Okay. So regarding the thing that on, log in, and those things. Okay. Is there any questions on that part? Yeah, maybe still have any.
I just have one thing to say, because I looked at it further and I found out that the actual insertion is a O of 1, but the access to that particular node is O of n.
Yeah, we could see that. We could see something like that. Yes, just like or like we have 1, 2, 3, 4. We have n students in the classroom. Okay, if we are go to Marietta campus on a bus, okay, probably that's the O1. But if we go there separately, it's gonna be ON, right? But if we all get on bus one by one, right, we cannot see that this whole thing is ON, because we just get on bus compared with the bus moving from here to Kennesaw campus. That's basically we won't count that part, right? So probably, yeah, like two algorithms to go from here to Kennesaw campus. One is we went on a bus, go there together. The other one is every one of us we drive a car to the Kennesaw campus. Okay, that's two different algorithms, right? But at the end, we all arrive there. That's two algorithms which achieve the same goal, right? But get on bus, but if we all go there on a bus, probably that's an O1 thing. However, if it's we all drive our own car, the cost is much higher than a bus. Agree with that part? Yeah, that's basically that's ON. But if we all get on bus, like we access every one of us, we get on bus n times, right? Because we n people there. We have n students here. So, but that n is not the main it's not the main contribution to that algorithm, right? It's not fair to say just if you think about it, is it fair to say that those two algorithms they both have a runtime of ON, bus and car? No, right? Bus is obviously bus is lower cost. Yeah, something like that. Help you to understand that. Yes. Yeah. Okay. So it's kind of confusing, like single linked list, right? Because if it's a single linked list, just what I mentioned, because the access we do have to do that n times, right? But let's try something like double linked list. Let's see. Okay, here, what I'm doing here. Okay, I'm gonna call it double linked list. Okay, if you still remember, we have cell. Next, also we might need a cell. Previous one, yeah, right? If you know what is double linked list, so double linked list looks like this. See, so here's a cell, maybe we call it item. So in between here is actually the data, right? This is the data. And at the left side, yeah, it's the address point to the elements that before this cell, okay? And this is a pointer to the next. Okay, so two pointers or references to previous one or next one. There's some special cases like the head or the tail, something like that. The head, okay, the link to the previous one, if it's head cell, the link to the previous one is now. And if it's a tail, the link to the next one is gonna be now. Let me make sure this is working. Okay. Yeah. The cell, and we have a constructor, which if we want new and we have new cell. Yes.
Is there a way that you can make it larger?
Oh yeah. We have that problem last time, right? The answer is I don't know.
You have to go to edit and increase the font size.
Font size? Oh yeah. Then where can I do this?
I think it's under edit.
Is this IntelliJ or?
This is NetBeans.
I think if you look at the top right hand side under the edit menu, I might have to change the font.
Top one,
Top left, I'm sorry.
top left, edit. It's easy. It's easy. See. Tools, options, font, color. Tools, options, font. Yay. Okay.
Yep, it's better.
Yeah, that's much better.
Thank you.
Welcome. Okay, so this is probably a cell, which is one item in the double linked list. And when we initialize it, well, probably if we create a new cell, we don't know what is before it, what is after it, right? So this two value should be empty. But actually, when we declare it, it's actually empty. So, but just let me put it here, then it'll be more clear. Next. Okay, so this is stale. All right, and then we will have another one, another class. Let's call it my double link list. Okay, so here's my double link list, right? So what do we do here is we will create this whole list there. For a linked list, when we are trying to access this linked list as an encapsulated data structure, we need some information there, right? How can we use a linked list? What is the maybe element we should have there?
What's the name that you re-access it to the head function or the head node?
Yes, yeah, exactly. One of them is head node, and
We have
If
tail
it's
node,
double-
double.
Okay, if it's double linked list, then we need to have the tail too.
What can you speak loud? Tail.
Yeah.
Yeah.
And if it's something that I wrote the same.
Yes. Yes. Good. So we do need a head and a tail. So what is the type of the tail? Head. Yeah. Yes. Great. And tail. Right. So probably we will have a constructor. So everyone knows what is a constructor, right? Everyone knows it, right? Great. Yeah. So when we have a constructor, if we do not give any, if we create this linked list without giving any information, so what we can do is only like put them as empty. Right? Yes. Okay, so now let's give some of the like operation. All right. Right now, if we want to play with a linked list, we need to do something like this. Like here, let's put it here. This is the entrance. This static void main is the entrance of the whole thing. Okay. So if we want to play with it, first we need to create a cell, right? So the cell is cell. My list. Okay. New cell. Let's just give it something like first a string. If you remember here, cell, I put it pretty general. I put object here, so everything can be put to the object, can be held as an object. So include a string. Okay, string is an object as well. And then well, yeah, probably if we need more cell. My list 2. Just put 3 of them there. Right, 3. Third. Okay. Then so we have 3 cells. Next thing is we kind of connect them because it's double linked list. It's gonna be something like one after another, but they are cross-linked. Third. Okay. And we need to connect them, so my list dot previous is now, because that's a head, right? My list dot next is my list 2. Right now we do similar thing. My list 2 dot pre is my list 1. My list 2, the next
I
is.
think you just have it as my list. There's no one.
Oh. Yeah, thanks. And then we do it for the 3rd. It's pretty tedious. 3. It's gonna be nothing. Okay. So that's basically a link from 1st, 2nd, 3rd. We should be able to have that, right? And if we're going to have a print function so that we can do it like easy tell what is inside. Okay.
Do we need to insert the data first before we print, or?
You mean the data?
Oh, okay, the
Yeah, let me just yeah, object is the data, yes. Void print. Okay. Let's just do something like we actually need my double linked list. My double linked list. Okay. So when we do the print, we just go from first to the end, right? Yeah. So we can do while so current list dot head. Yes. Okay. And then we kind of go through it. It's not empty. Well, we
Was I gonna check to see if the data is empty or if the next link is empty?
well, you can have a cell there, but holds nothing. That's okay. But you cannot have a empty. No, the you have a space there, but it holds nothing. It's okay.
Yeah.
So
I'm saying, so when you do current is not equal null, is
Right.
it looking at the data value or is it looking at the?
no, it's not. It's not checking the value. It's just checking if there is a space
Oh, anywhere in
for
the-
the cell.
Okay.
Okay. Print. Yes. So it could be something like yeah. Plus dot data plus yeah, okay, something like this. Probably we need toString. Yeah. Because that's an object. Although it's a string, but it identified that as an object. Right? This we assign string here, but it actually identified that as an object. Okay. Yes. Okay. And here we have all those cells, but we forgot we still need a linked list itself. That's crazy.
I think you named it my double linked list, not linked list.
Yeah, my double link
And you added ED, right?
linked. Yeah. Head. Yeah, so this is what kind of create that thing. Maybe tail. Right here. Okay. Let's call this my print.
Why you need another, right?
What's that?
In the while loop, you need to go to the next node. Currently
Oh yeah. Yes, yes. I forgot the part. Let me do this. Okay. That's fine. Yeah. Okay, let's see what's gonna be printed. Yeah, we're gonna finish it.
Increment current in that
Yes, yes.
application.
Just need current next. So ideally, it should have something printed. Yeah, so if we can see, well, is this result? Let me copy and paste it. Okay, so basically it looks like something like this. Linked list first, second, third, something like this, right? Okay, then that's like create this with without the operation, any operation in the my double linked list, right? But now we want to have some operation here. Just we can be more convenient to access those. Yeah. first we need that aid function, so that we don't have to do like this next. Oh, actually, here I forgot one thing. Yeah, no, it's okay. So that every time we create a cell, we kind of put the pre here and put the next there. We control every like pointers there, but we don't want to do that. So that's the amazing part of object oriented, right? We treat this as an object, so that object have this operation there. We just need to call this operation to do this. We don't have to like manually manage all this like links in that code. So we will have some add function. We add, in a linked list, we add a cell into it. Right. So if tail is noun, we just put it as tail, right? So if a tail is noun, if tail is nothing, that means head is nothing. You agree with that? No? If we have one element there,
Yeah, both will be pointing to the
right? Both will be pointing at the only element there. Right? Yes. Else tail dot next.
Should that be where if head is null, then both head and tail are set equal to X?
Well, that's the same over here. That's the same.
Okay.
Yeah, it's the same.
Please, what is X there? What is X?
X is the cell we want to add into this.
Okay, so, okay.
Yeah.
Should be.
Tail next. Yeah, is X, right? Yes, tail next is X. Yes. So we don't need to like go from the first to the end to search for the empty space, because we know where the tail is, right? So what else do? We put X there, okay? And then we break the old links, like establish the new links, right? So in order to break the old links, we need to do like, we already break it actually, tail next. So we need to establish the new link from the old tail to the new tail, also from the new tail to the old tail, because it's double linked list. Tail, right? But you cannot reverse this too, because once you change the tail, you're not able to access that. Like x.pre, you put it as a self, right? Yeah, so that's what we do in this add. Right? So with this function defined there, we actually, if we want to print that list, like create a list, print a list, we don't need to do this. this whole tedious thing. Like pre, next, we don't need any of them, but we still need to create the linked list, right? Create the linked list, and okay, and we do not need this check the head tail thing. Okay, what we need to do is just call the add function, right? See, we remove 8 lines of code, but instead we just need this. Add my list. Okay, smart. It knows what I want to do. Let's see. Okay. So all the 8 lines, I guess, 8 or 9 lines of code are replaced by the 3 lines of code, and it's more tight, more clean in this area. You know what we're doing with we defining that function inside that object. Okay.
Question. How do you understand the tell next part?
Which one?
Under the my to-do list part?
Yeah. This
No.
add.
Like on the other module.
This one.
Yeah, tell them next. How is it X?
Yeah, because okay, so this is a situation that it's nothing in there. Okay, it's simple. We put things in there, put it as head and tail, and here when we reach here, that means there's something there, right? If there's something there, we add a thing to the tail of the old list, right? Then we need to change. We need to connect the old tail to it. So the old tail's next is gonna be the new cell, right?
Shouldn't that be pre instead of next?
Pre.
Yeah. The previous one.
Let me.
So the tail is just a marker that'll point us to whatever the last cell is in our linked list, right?
Yeah.
And so all we're doing is pointing into the last one.
Tail is the last,
Yes.
cell.
Tail is the last one. It's.
But what we're doing is we're actually adding one on to the end of it, and then we're just saying this is now the tail.
Yeah.
Saying so that what we call the tail is someone's really pointing to the last one.
Yeah.
Okay, so there are 2 pointers. This is head. This is tail. It's head. This is tail. Right? There are 2 pointers, like to address in the memory where are those things, and then we have kind of this double linked list from here to here, from here to here, similar. Okay, and this next is point to nothing, and this pre is pointed to nothing. Okay, I should have this. Okay, now we have a new cell called X. We have new cell X. We want add it to the linked list, right? Now what we do is, so this is the tail, right? This last tail is the tail, right? Tail next is this arrow. Agree with that? So we change tail next to the X. We point tail next to the X. That's something like, so right now this is no, right? But when we add we'll change that value. It's not now anymore. It's now gonna be pointing to the x. Okay. That's why we put tail.next with x. Alright. And then also we need to put x pre put to the old tail. Like this. Right, and the rest thing we do is we swipe this tail pointer and we change it to this. Okay, so that's what we do here with this 3 thing. Tail next, x pre, tail, and tail we assign it with the x. Okay, so here we 8, 8, 8. 8, 8, 8. Let's see if we run that, will it be the same with whatever we got before? Okay, so it's pretty good. Let me show you this. It's the same. So first, second, third. Alright. So we successfully replaced that tedious and complicated code with some neat code there. Just with the help of that object design, okay? And then let me do one more thing, like we have add. Let's try another thing, remove. And we have a lot of functions we can do, but I won't do everything here. Just let you know the idea, okay? Now probably need a new method. Like add. Why should we start from here? Remove. In remove, what we remove? We remove a cell, correct? Cell X. So theoretically, what we need to do is just break the link, create a new link, right? Because we already have the cell X. We know what's after it. We know what is before that, because we have pre and next. So what we need to do is x dot pre dot next x dot next. You understand this part? Just the previous one's next. It's supposed to it is pointing to me, but I want it to point to my next, so that it breaks the link between me and my previous one. All right. X dot next dot pre equals to x dot pre, right? So does the next. All right. So this two parts. Like, theoretically, we just need to do this. However, unfortunately, there's some special cases we need to think about. That's the head and the tail. Yes, head and tail. Because you can, if you are in the head, this will pre x. If you are the head, x is the head. You say x dot pre probably will give you this non-point exception. Okay, there will be arrow there because x dot pre is null. You can not see just null dot x next, right? So we need to we do need to consider something like that. So we need to take them out and treat them differently. So if x is tail, we need to do
X dot pre dot next equals null.
well, no. Let's see, x x hat. Start with hat. If x is hat, and we have different considerations. If x is head, and it can also be the tail, means there's only one thing there. So we need to treat them differently. So that means if it's head and it is a tail, okay, what we do is we want to that's simple, right? If it's head and tail, we just put everything now, then it's done. Okay, and since it's Java, so we don't need to actually take care of that space. So if we want to remove that cell, if you're doing that in C++ or something, after you remove the cell, you also need to swipe it from the memory. You release that space in the memory. But in Java, it's different. In Java, it just like collect. It will detect, okay, this object, this space will never be used anymore. Like no program is gonna have access to that. It's not gonna be used anymore. It will like release the space, collect the space. Okay, so that's Java. Java does that all that for you. So basically, we just need to put the pointers to now. That's it. Okay. If x is head and it's only one element, but sometimes it's not always only one element, right? So if x is only the head, we just need to do next, right? We just need change the head. We change the head, and head dot pre, right? Because x is the thing we want to remove. If it is a head and it is not the tail, what we do is we give a new head, and the new head point to nothing in before it. Okay. Alright, so that's when x is a head. We also need to take care that if x like else, okay, if x is not the head at this moment, if x is not a head and it is a tail, and if it's tail, so tail x dot free, right? We change the new tail, and tail dot next equals to no. Yes, you got it. Yeah. If x here is x is head here, if x is not head and x is tail, then we have some other thing we need to consider. If x is not the head and x is not the tail, which is like most general, most of the time, most of the situation. Okay, that's what we have already done here. Just put this in this part. Put them in here. Yeah. So that's basically how we do the remove. Okay. However, like if you do not have this function here, if you want to like do some remove with what we previously did, it's gonna be right, headache. Yeah, maybe you need to spend the whole long weekend on that. Just add and delete, right? But here, once this is done, we just need to call it, use it, right? Also, that's a linked list, double linked list. Also, the list can have different implementation. Okay. Here in this my double linked list, I can use this double linked list, but also I can use single linked list array, but we do the implementation here in this class. Okay, we can call it something more general in this class. However, in here, like Java, like this, we can still call this add, and we can still call this add, and we can still call the delete, remove function. It won't change anything in the main thing, in the main program. In the program that uses this list, it won't change that part. Okay. However, if you are like putting all those add, delete, if you are writing them here in the main program, when you switch to another implementation, right? When you switch to another implementation, it's gonna be yeah, you will change everything. Yeah, it's hard to manage that. Okay, but here you can change implementation of that structure, data structure of that ADT. Then you can still use it same way. Okay, like different implementation has different, like the domain, like different domain. They may prefer different the different domain. They prefer maybe different implementation. It's not like just array is always worse than the linked list, because linked list is dynamic. Array is like fixed. But if you want it to be dynamic, you have to have more way to manage that, like double that again and again. However, as we mentioned in the last class, right, it's not like always like when we want to remove something for all the operations, it's not always like array implementation is worse than the list, than the linked list, right? You remember something like get something, get the second element. It's much faster in the array implementation. So, well, different implementation will have the influence on their performance, runtime performance. Okay, so but it has influence. It has a negative and positive influence on different operations. So when you are designing and choose what is the implementation, you need to take into consideration of the application domain carefully. Like if I'm only gonna, like, I do not use that like I remove a lot. I just read them a lot. Okay, or I just want to select the ends number. I use this a lot. Maybe probably you need to use the which one? Which one? Array? Yes. Probably you need to use the array, yeah. But in other case, if you like linked list, which one is better? Yeah, like remove. Okay, if you use like this list changes a lot. You add, you remove it. Okay, if it's an array, you need to wipe that data out, and you shift everyone like to the left, like one space to the left, or yeah. If you're using that a lot, probably you need a linked list or double linked list. Okay, so take that into consideration. Okay, so that's when you implement that data structure. But when you design the data structure and use that data structure, that's in the design level, not down to the implementation level. Okay, so you just need to decide which function should this structure have, should this object have. Okay, and you leave the performance thing later in the implementation stage, right? But it does has a different implementation, does have a lot of influence, big influence on the performance. Okay. Yeah.
Can we use multiple data structure in the same application when considering performance?
You mean multiple data structure?
Yes.
Yeah, you can use like data structure. You can use just I'm gonna use list, okay, and list has different implementation. All right, I have a linked list. I have a array list, right? So what we do, yeah, we can use both of them. But when we design our system, we are not thinking about those implementation yet. We are just think about we use list to do something. And later in implementation, yeah, I think I'm using this linked list for removing stuff. I'm using another list for accessing, but that brings a problem. How you need to like synchronize. You need to keep them consistent if you have two lists, right? Because if the two lists, they actually have two different spaces and they do not synchronize like automatically. So you need to keep them like the same every time you do some operation. So still, yeah, but we do use different kind of lists in our program. Okay. But it's a list of the same thing. I thought if you want to use two of them, to keep two of them, yeah, to maintain two of them, yeah, that's gonna be a little bit hard. Yeah. Well, that's some other question. We may talk about that maybe when we talk about the design. All right. Okay. Now let's continue. Let's go back. Go back to OO. So we talk a lot about data structure, ADT, as an example of maybe object-oriented design, and also a little bit I want you to record those data structure knowledge a little bit so that it may help you in the future study. Okay. Now something else. Let's go back. Okay, I missed that page. Yeah. When we're talking about something special in object-oriented design, it's kind of inheritance, right? Inheritance. You still remember what? Okay, not inheritance. Okay, so like I talked about three ways that we get to learn this word. What are those three? I think I mentioned that in the first class.
Classification.
Yes. Yeah. Classification. Aggregation. Generalization. Those three of them. Okay. Hope you still remember what are the. And yeah, you know what are the, but maybe you cannot map between those words to the meaning. So yeah, it's okay. We'll talk about them here. Okay. So aggregation is kind of easier, right? So it's basically if we just use one word to describe aggregation, what is that?
It's part of?
Yes, it's part of. That's not one word. That's three words. Right?
It's a hyphen.
Yeah. Okay, I'm wrong. So maybe two words, connected two words. Has a. It's easier than it's one part of, right? Has a. It has a relationship, aggregation. Okay, and how about is a? Which one is a relationship?
Classification. Aggregation is part of, right?
Aggregation is has a.
Okay.
Yeah.
All the slides is part of.
It's part of. Yeah, the same. It's part of a has a. 'Cause you yeah, like I have a head. A head is part of me, something like that. Okay, so it's basically same thing. Yeah, and is
It's a generalization.
yeah generalization. Yeah, is okay. So like the difference between is and has is that clear? Yeah, maybe it think sort of clear here, but when you get to some real world problem, probably it's hard to decide if I should do it as a has a or is a relation. Sometimes it's hard. Like like student class. All right, we have student class. Then we have some some other class, another class called part-time student. Then we have another class called full-time student. Okay, we have 3 classes now: students, part-time students, and full-time student. Those 3. All right. So it's. Do you think the like part-time and full-time student, they should be subclasses of student?
Yes.
So it should be is a relation? You think so? You think so? But in some scenario, we can design them as has. It's not necessarily always true. Always true there. So like think about yes, inheritance is cool, yes, but you cannot just say the more you use inheritance, the better your code will be, because like here some situation. Like okay, so we have this classification: student, subclass, part-time student, and full-time student, right? But there are a lot of cases the students switch from part-time to full-time, or switch from full-time to part-time. But if you create that instance, if you create a student with like full-time student, when you want to switch, you need to destroy the old object and create a new object. Understand that? Yeah, because although they are all student, sometimes you initialize that student with a full-time student with that class. The student is an instance of full-time class, full-time student. But when he or she change, you need to create another student and copy all the information from here to there.
I don't think you need to create a new one.
Yeah, why don't you think so?
The difference between a part-time student and a full-time student depends on for example, the methods implemented from the student class. So,
Inheritance from student class.
Yes. So if those methods are not implemented in the part-time student class, when you need it to be a full-time student, you just have to implement those methods.
Okay, so you cannot just then those two classes become no difference, right? Become more and more likely.
The only difference is
to
that
each other.
the full-time student probably implements all the methods in the parent class, and the part-time student doesn't.
No, it's not. Then it's different. Well, okay. So if it's part-time student may have different operation. They may have like paid tuition operation. They all have paid tuition operation, but the implementation may be different. right? So when you switch, you cannot force that object to grant it with another type, like here.
Yeah.
Okay, so here is a student class, subclass. No, why would I use this? Okay, it's fine, just use this. Real quick. Okay, so this is a student. This is a part-time student. Full-time student. Full-time student. Okay, then we have some instance like Mike. It's gonna be an instance of it's gonna be of the type of a part-time student. Okay. It's a part-time student. He's a part-time student. Okay. So now Mike decide to switch to full-time student. Okay. So let's see some different operations here. All right. So part-time student has what? Register class. Well, what's the difference between part-time and full-time?
Number of credits that
Credit, yes.
Yes.
The amount, like, added.
Okay. Yeah. Check status.
Check status.
Like check if you meet the criteria of part-time or full-time. Okay.
Okay, I wouldn't put that there.
well,
They have to
The
be
way-
about
the way I thought about it-
Six credit.
Okay. They both have this. They both have this.
Yeah.
Check status. Okay. They all have this same functions there. Okay, and it return a boolean, tell you okay, okay, if I check like part-time student, I check status if you're greater than 6. Here the check status is if you're greater than what's that?
greater than or equal to 9.
Like 9, yeah. If you're greater than 9, okay. So they have this same method, but with different implementation, okay. And then Mike decided to switch to full-time, okay. But Mike now he's an instance of part-time student. Like we'll use some dash to say this. Okay, it's a part-time student. So right now Mike checked status. Okay, 6. We meet the criteria, right? When we call Mike dot check status. For example, Mike registered for 7 classes, so 7 credits. Mike check status will return true. Okay, but now Mike's decide to switch to full-time student. What can we do now? So like you said, we need to like add a method.
Yeah, what I would do is just have all the methods that a full-time student would have in the parent class, and then create a limited version for part-time students. So when you create a Mike as a student, when Mike wants to switch between part-time or full-time, it just depends on the methods he implements. It does not depend on the actual creation of the object. That's what I thought about it.
So what you're saying is that this implementation should be in the parent class,
Yes.
not in the
Not in the subclasses.
Yeah.
Because there's no need to write the same code twice.
That's not the same code. That's not the same code.
No, but it's the same functionality, right? They're checking status, right?
But there will be some difference.
Yeah, there will be
See,
difference
just
in the
only going to
implementation.
parent class, right?
Yeah.
What is the difference? What would be the difference?
No, if you want any difference, you can have, okay, like instead of having check status.
Exactly,
you have-
that's what I meant. So if it's in the parent class, each subclass can implement it the way they want.
Yes.
What I'm saying is that to change from a full-time student to a part-time student, you just have to change the implementation, not the
But
creation.
I mean, that is right.
So-
See, the student now, if he belongs to the part-time student class,
Yeah.
okay, if he has been created that object as a part-time student, you cannot simply reassign it to a full-time student.
Okay.
But if
Yeah.
the object was created for the student class,
Mhm.
then you can reassign it.
Yes. Yes. But now let's see. We have this check status function here,
Yeah,
which is maybe empty in the student class.
yeah.
Okay, and then we pick up different implementation in part-time and full-time. Then okay. The point we have this part-time student and full-time student. It's like we are using that to create a new instance, right? But if you are like if Mike is initialized from the student class, yeah, you can force it to switch the type. Yes, of course, but it makes this inheritance unnecessary. We can just define a value inside this student, like type, part-time, type, like full-time. Then we do not need two more classes, right? However, we here when we make design decision, like we need two more new classes, it's because it kind of facilitated us to like use this new classes to create some new instance, right? So at this status, like when Mike switch from full-time to part-time student, part-time to full-time student, it's a kind of a example that tells you that it's not always good to use this inheritance. Okay, it's not always good to use this inheritance. Here, in this case, you cannot just switch Mike to full-time student, change Mike's type. Okay, you cannot just do that. Yeah, you cannot just do that. And so in order to do that, you need to create a new Mike in the full-time student. Okay, so better way is maybe we do not have these two classes. We just have student class. Then we specify the type in the class. We can select if Mike is full-time or Mike is part-time. Okay, we will talk about this, continue to talk about this next time after we come back. All right, thank you very much for today.